All right, I'm just going to wait a few moments here. Wait for folks to come on in. Give them a few seconds. Yes, hello. There's one viewer out there. I can see you. All right, let's get this show on the road. Howdy, Houdini fans. It is 3 o'clock. It is Friday, and that means it is time for Houdini Secrets Live. Hi, my name is Chris, and I will be your host for today. And we will be going over some really juicy stuff today concerning VAT, or the Vertex Animation Textures, Vertex Animation Toolset, whatever you want to call it. We're going to do our third of 3 lectures dealing with VAT, and it is groovy stuff. Because today what we are going to be doing is going over fire, liquid, and volumes, and other kind of volumetric kind of surfaces. Things that you were thought impossible to create within real time, we are going to create in real time. And so, also, before we get started, DL from last week had a question about Roberto. Let me see if we can go into this. And the question was, let me see if we let me see if I can pull up UE4 here and go to VAT. And so where is VAT hard? All right, and so we have a level here. Well, there is Sluggo, but let me see if we can focus on that's not Roberto, it's Squidward. Squidward blowing up. And that is an obnoxious magenta color. I am sorry, folks. But DL had a question last week. He said, can we put flaming streamers of smoke, and I imagine fire in there, for every one of these particles? And the answer is, of course, yes, we could. But I didn't have an answer for you last week, and I did not have an opportunity to flesh out an answer for you for this week. I apologize, but needless to say, we try to get as many things in as possible as we can. However, I do have the solution for you. Okay, this all has to do with the fact that what we're dealing with is really a particle system. Huh? A particle system? Yes. At the center of every one of these chunks is a particle. And therefore, what we're doing is we're exporting the particles, or the vertices, position, and its orientation on a per frame basis. Now, we exported it through Houdini and into UE4 via the Vertex Animation Toolset. But if we wanted to create flaming, smoking chunks of Squidward, well, we couldn't use this information here as it exists now. Why? It's because realistically, we don't have anything to work with. All we have is a mesh. All we have is, this is our hard mesh. This is what we have to work with. There is no joints in here. There are no joints in here. There is no bones. There's nothing to attach to. How would we possibly get anything from here and attach the stuff to it? Well, we would still use Houdini, and let me see if I can demonstrate how. Let me see, move this back up here. Let me get rid of that. Okay. Okay, the answer is that if we go back into Houdini, let me see if I can pull up good old Squidward. And, okay, VAT hard bodies, that's what we want. Okay, we know that we're working with Squidward, but it all comes down to this Squidward here. If we go into this geometry node, then when we play, that's what we end up seeing. However, that's really not what's going around. Because if we look at this DOP import, if we take a look at our geometry spreadsheet, we see that it's not squid. I mean, the Squidward is, okay, 20,000 points. However, when we look at the DOP import down here, we see that it's only 228 points. Okay, so that tells me that there are 228 points of information being exported there. If we look at more of the information, the spreadsheet, we see that we got position, and then we have bullet information, and we've got density, all that other kind of wacky stuff, friction, all other kind of simulation, but we do have normal. We have orientation. We have pivot information. Pivot information. There you go. We have got rest position, and we've got velocity. And those do change on a per frame basis. So, what that tells me is, well, we've got Squidward blowing up in game. So how would we go and we effectively need to parent an emitter for every single particle? And that is done using not vertex animation tools, it's using another tool. If we go into our ROP network, and what we are going to is also a labs tool. If we look at our labs, we can see something called Labs Niagara ROP. Okay, if we go into there and we tell it which SOP to export, which would be our DOP import, and then we export it to this HBJSON file, then we should, technically, theoretically, be able to go into UE4, open up Niagara, read in that data, because Houdini has this awesome Niagara plugin that you have now that you should be able to bring in. I don't have it installed in this build here, but maybe that will be something that will happen in the future. But we can bring that in, and therefore we can take that particle information, and then for every one of those particles information, we can turn it into an emitter inside Niagara, and then have it put out streams of blowing clouds and smoke and fire and all that good stuff. So, in effect, what we have here is multiple layers. Would each of these actual rock chunks be emitting smoke and fire? No. But within each of these chunks would be an emitter that would emit smoke, fire, debris, all this ugly stuff. And the audience would never know the difference, the fact that we're dealing with multiple layers. We have the actual exploding Squidward layer, and then we have the flying particles layer. And the flying particle, or the flying emitters layer. The flying emitters layer is going to emit all your particle streams. So that's how I would go about doing it. And I am fairly confident that that is the best and the quickest and the easiest solution. I could think of some other solutions as well, but that is what I would go for. And if you're unsure on how to actually do this, my suggestion would be to go back to Houdini Secrets, rewind the clock, about 6 months. Go to about July 17th. I created a Houdini Niagara interface broadcast for Houdini Secrets on July 17th that explains exactly how to get Niagara talking to Houdini using that exact Niagara exporter that I just told you about. That will tell you how to do it. Sorry I can't do it for you and give it to you directly this way. But I figure a little bit of something is better than nothing. So thank you very much for your patience. So this week, what we're going to do is go return back to the VAT toolkit, but instead of creating things like a wrapping cloth that are very solid, and then we have blowing up Squidwards, which are not very solid, but they actually really are solid objects. What about if we don't know how many polygons we're actually going to deal with? We know that even though this Squidward here is thousands of polygons, we really know it's really just translated to 228 individual particles. That's all we really know. And that is exactly the kind of information we want. But what if we don't have that information? What if we have is the number of polygons changes? Well, VAT has a solution for that too, and that's what I'm going to show you this week. So I'm going to create a brand new project. Well, actually, I'll stay with the same VAT project, but we're going to create something brand new. Oh, golly, look at me. I forgot to give the broadcast for this. I didn't actually show you anything. But let me go ahead and turn on my lecture. I forgot to broadcast my screen. Oh, joy, the joys of live broadcast. Well, the person who is currently on obviously has been eating Tom and Jerry's, Ben and Jerry's ice cream because they didn't send me information. Said, hey, dude, your broadcast, you're not showing your screen. Ah, que lastima. Oh, well, I'm going to have to talk to my IT department about that. Okay, well, let's get back into election mode here. Ah, much better. Okay, let me make sure to activate my camera. Okay, there we go. Cancel. All right, now you haven't been able to see what I've been showing you on the screen for the last 8 minutes, but that's okay. Check out the Houdini Niagara interface from July 17th last year. It will show you exactly how to get your Houdini particles, in this case your DOP import particles, export them all the way to Niagara, and then you can go and particle to your heart's content and create lots of flaming Squidward particles, kind of like he blew up inside of the lobster boil, and it is just, and he's just burning down the juicy crab. All right, so let's get going. So what I'm going to do with is I'm just going to go ahead and who we're going to create today. Who are we going to create? We work with Squidward, and then we work with Roberto. What if we use Stash? Yeah, okay. Let's put down some Stash here. Okay, let's see what happens. I've never used Stash before, so let's see what happens. Rolling the dice here, just asking for trouble. I just never learn, I guess. Okay, so I'm going to put my Stash object here. I'll call it Burning Stash, because what we're going to do is we're going to burn Stash up at the stake here. Okay, Burning Stash. Okay. Kind of a drop down a test geometry, and there we go. There he is. I don't know, his name's Tommy, but I'm going to call him Stash instead. I can remember Stash. I can't remember the name Tommy. Okay, we're going to light Stash on fire here. Okay. We're going to get all incendiary on him. All right, we're going to start off. You know what? Let me think. Maybe I shouldn't use Stash. Stash is kind of tall. And I'm thinking for broadcast purposes, this may not work. So what else do we have here? Who do we have here? Oh, okay. Well, this is good. Okay, we have the head. Why not? I was just going to call it Dude. We've got the Big Lebowski on here. All right. So we've got the Dude here. And we have to change the name to Burning Dude, just to be consistent. Okay, we've got Burning Dude here. Okay, Burning Dude. What we're going to do is light him on fire. So I'm going to go ahead and grab my Pyro folder, but I don't have my Pyro folder in here, so I'm going to go to Shelves and choose my Pyro folder, Pyro FX. Yes, baby, that's what we want. And so I'm going to make sure Burning Dude is selected, and then I am just going to go and flame on. Just going to hit flames and turn him into an incendiary. Woohoo! Look at that. What is going to happen here? I do not know. We're going to have to find out. Okay, if we go into here, hit enter, and then flame on. All right. All right, we've got some juicy flames here going here, gang. Boy, that's a strong fire. That is really buku. That is really intense. Okay, that'll work. Yes, sir, Orville, I think it'll fly. All right. So what we're going to do is we have to go in and isolate these components. So we're going to leave this right now. And we're going to leave our burning man, or burning head, right there for a bit. And then we're going to go in here for the DOP import. And so we're going to have this import pyro fields, and we're going to work from this. And we're going to click this, and then here we have all of the way that the fire information is visualized here. And then where it says heat visualization, heat, what we're going to do is change that from smoke, we're going to change that to rainbow. All right. And then what we're going to do is we're going to isolate the smoke, which is also known as the destiny. No, the density. I'm just kidding around. So what we're going to drop in is a delete node underneath there. And I'm just going to say smoking, because that's what we got here, is just the smoking. What we want to do is just get the density. So where it says group, we're going to change that to @name equals density. Now we want it to be equals, not minus. Okay, @name equals density. And if we play this, everything should be gone. No, it is not. Oh, because we didn't display. There we go. There's our rainbow. All right, there we go. Okay, drop in. We've got the delete node under the pyro import. We're going to rename it to smoking. Our name equals density. And then we're going to delete non-selected. Okay, so we should have everything but the smoke here. And let me see if they got name equals density. @name equals density. Okay, where is it? Density. Let me pull that in here. @name equals density. There we go. All right. So that is going to give us our density. And now what we really want to do is select our heat. So I'm going to drop in another delete node out here. And then I'm going to call this fire. You know, just like Beavis and Butthead. Fire, fire. Give us some fire. All right. So I'm going to go here, and then we're going to select the heat. And so it's @name equals heat. And now we're going to go app operation equals delete non-selected. Okay, we'll click that. And there we see, this is just our fire. But we are making a look at it so it's rainbow. But it's real interesting because our fire there is all kind of jiggly, and it's got all these kind of undulations onto it. So that's exactly what we're looking for. All right. So we've got the fire selected. Now let's go ahead and write this out to cache, because whenever you're working with incendiaries, it's best to work with cache and write things out as often as possible. So I'm going to drop in a file cache node. And I'm going to send the geometry file, and I'm going to, let's see, do we want it? Yeah, we'll put it in here. Let's see where we want this to go. I want to go in, I don't want to go in, I think I have the export and scripts, sim. Okay, here's my sim, where we're going to save this stuff, and I want to create a new folder. I'm going to call this dude. Okay, we've got the dude. Job sim dude. Okay, accept. I'm going to cancel this. I'm going to put that as the folder here. Oops. Job sim dude. And the name is, I'm going to call this dude fire. Dude fire $f.bdo.sc. That's exactly what we want. And let's go put the whole 300 frames on here. And then click on load to disk. It's going to give us an error because those files don't exist. So let's go ahead and save this to disk and bake it out. Whee, that was fast. All done. Het Roy. So what we have to do now is make a loop. So I'm going to go ahead and put my display onto here, and I'm going to look through here and see where the best loop or some kind of beginning and end that kind of look like each other. And I see kind of something that looks like horns coming off of here. So it looks like a column. Here, let's say 400 or 140. And, oh, let's go. Oh, that's pretty good. 140 and 217. I'm going to write that down. 140 and 217. So not quite 100 frames. Let's see, do we have anything better? So 140. Actually, this is actually pretty good. This is over 100 frames. Let's go 100 to 140 to 260. Yeah, that'll work. I like that better. 140 to 260. Okay. Now, we're going to drop in a make loop SOP on here. And this is from the labs, yet once again. And these labs guys are all over the place. I'm going to click the display on here. I'm going to right-click on the start and go delete channel and the end frame delete channel. And so what that did was it deleted the channel that was currently there by default. And I'm going to just type in those numbers that I figured out at 140 and then to 160. Okay, and what this does is it's going to blend the end with the beginning and then kind of get them to kind of make it look like they're working together. So if I change the start and end frame range of my timeline, so 140 to 260, if we play this, it should technically look like one continuous stream. And I'm going to put this on real time. Okay, we don't really see a loop, but we do see this column of fire that is pushing out here and really blending along here. Now, this debris in here isn't going to make it across here. We don't really want it. All right. I'm going to save this just because I'm having one of those kind of days. Save as, and I'm going to call this Fluid Dude. Sounds like a Drew Estate cigar. Fluid Dude. Okay. All right. Now, we've got this saved off. Let's go ahead and create a mesh. And so we're going to create a mesh. We have to convert it from a volume to an ISO offset. And so we're going to turn it to an ISO surface. So let's go and create and drop in an ISO offset SOP. ISO offset. All right. And now for the output type, we don't want the ray intersect. What we want is the ISO surface. Bum, bum, bum. Metaballs, point cloud, no, that's not right. Okay, output type, fog volume, no. Well, it would help if I was doing the right menu. For the output type, you want ISO surface. You don't want fog volume. Leave the mode right in ray intersect. But actually, now that I'm talking about it, change that mode. Change it over to sample volume. All right, where it goes right here, where it goes right here. All right, volume sample. Yeah, change it over to volume sample. That's what we want. And that's what we're looking for. We're looking for actually stuff that's going to turn this actual into some real geometry. So what we had, what this SOP is doing is it's taking the volume and then it's converting the volume's manifold, which is its outside surface, into some polygonal geometry. And then where it says uniform sampling, change it from x-axis to by size. And then we're going to adjust this division in size until it comes to something that kind of like looks good. It would help here to make it smaller. No. So let's go ahead and make this a wee bit smaller. Okay, we got a volume sample, and this is looking like the dickens. I tell you, this is looking terrible. I don't want this. This is not good. All right, so this is not looking good. Good data. That's what I get for using some data that I've never used before. And so what I'm looking for is some higher surface detail, and we're just not getting it. And so I'm going to go, and we've got my ISO offset. Oh, yep, and this is now an ISO surface, output type, and the volume sample is this. And then, and so they adjust the offset until the fire shape appears, and my offset is, oh, that's my division size. And so I was doing the wrong parameter again. I'm going to revert to defaults. And how about if we increase this to maybe something like 0.1? And then if we were to play this, yeah, we're starting to see some kind of like fiery shape out here. And that's good enough. All right, so let's go for this for now. And then we're going to turn on the back face culling. Let's see if we actually dial this in actually more. Ooh, look at this. Ooh, now we're getting some real good data. Ooh, that's really small though. Okay, it really slows down to a creepy crawl. But we have these billowy flames that are just kind of going up here. Let me see if I can make this a little faster here. If we double that, will this look a little bit better? Yeah, that kind of like looks like something from a sci-fi movie. Could this be fire? I think we can make it work, folks. Okay. Oh, there's the division size. Then we go into the offset. I keep on changing these, the division size and the offset. Let's see if we change the offset. Is this going to have an influence here? All right. Yep. Okay. And the division size. Okay. Yeah. Let's leave it at 0.2, and we'll just play it by ear. Okay. Let's go turn the back face culling on. Okay. The ISO offset turns the fire inside out. Why does it do that? I do not know. Someone who really knows ISO offset needs to inform me. So if you're out here, please go ahead and drop it into the comments and tell us why the ISO surface reverses things. So what we're going to do is we're going to turn on to remove back faces. So we're going to remove the back faces, click true, and then we see, ooh, it looks so much better. That's different. And then we're going to see what happens. So now the fire is inside out. But hopefully it is now a little bit more behaved. All right. Now all we have to do is the fire is inside out, so let's go ahead and reverse it. So let's just go ahead and after the ISO offset, put in a reverse stop. All right, so we've got it inside out, and so we've got so let's make them right side up. So let's go ahead and put in a remesh in order to kind of remesh this and kind of make it look a whole lot better. So I've got the reverse, and I'm going to append a remesh stop. Ooh, look at that. And that doesn't look good. What we're going to do is increase the iterations and the target size, length uniform, adaptive. Yeah, that's what I thought. This is way too much. So let's put the iterations back to like something like 3. It's thinking. Okay. The relative density, let's change this to 1. I'm afraid we have too many points here, folks. And so for the gradation, nope. Make it a little bit bigger. Okay. There we have some nice billowy fire here. All right. Cool for cats. Okay. Now what we're going to do is put an attribute blur sop in here to kind of like smoothen the surface. We'll see if this makes things look a little bit better. So I'm going to drop in an attribute blur sop. And then we're going to click that to see if we can actually get this. All we have to do is get our step size and then modify this to see if this actually makes a difference here. I actually like it when there's a little less of the attribute blur. Okay. That kind of works. Okay, let's go ahead and simplify it down to something that's a little bit more manageable. So let's drop a poly reduce on here and lower those number of polygons. All right, how many polygons did we start with? Yeah, about 9,000. That's a little bit heavy. Let's see if we can get this to some kind of that's a little bit more manageable. Well, let's go to see if we can knock it down to around like 2,000. So percentage or output polygon. Let's move that down. Okay. And let's go down. How about output point count? Okay, I'm not getting any good stuff out of here until we go all the way up to 2,500. Here we go, 2,500. If we go, and how does this play? Darn slow, that's what this does. But here we have is the shape of our fire, kind of like billowing out here. Okay, so this is all taking a very, very long time, and I think we're going to have to spend some time baking out. But before we do that, I'm going to slap some normals onto here. All right, so we've got, and set the normals to points. We need that in order to get the VAT stuff to work. And let's go ahead and drop in some color information. So we're going to drop in an attribute from volume. And then we have the 0 coming in from there, and so we want to get the other coming in from the import pyro fields or from our file cache. Where's our file cache? Get that over here. We're going to stick that in there. And we've got some wild looking stuff, but what we want here where it says volume, and then we're going to type in the word heat. Okay. And then we're going to go right into the mapping tab. And then we're put the input range. We want it to go from 0 to 5. Okay. Then we're going to map the volume where it says map volume to value. Set that equal to true. All right. Then we're going to dial in this left marker of our scale ramp to see if this gives us any kind of good contrast. Well, it kind of like is there, it kind of just gets homogeneous all there right again. All right, we've got our color here. We're going to change the color anyway. I don't really like this black. But let's write it out to disk yet once again. And so I'm going to create another file cache. There we go. All right, so we get the first file cache node. What I'm going to do is, we got that. I want it to go from here to there, but I want it to go from 140 to 260. So I'm going to go and delete these channels, and I'm going to type in 140, and I'm going to put that in 260. All right, so those are the numbers that work for me. I'm just going to leave those. I know it's hard code, but this is just for a little test here. And then we've got, and we're going to call this fluid dude fire. Okay, and we're going to send that to the geo. No. And here we're going to go to our sim and dude. And we call it dude fire, and we're going to call this. We're going to call this dude fire loop, and I call this $f.bgo.sc. All right, we've got that working in here. Now we've got all this set. Load from disk, and it's going to fail. Okay, let's go ahead and get this started. Let's get this party started. And it is plugging along and chugging along. It's got to go and do this all the way up to 121 times. Okay, it's plugging there, it's chugging there. All right, now let's talk about what we're going to go on next week. Next week, we're pretty much finished with our VAT exploration. So one thing that I've always wanted to learn is crowd systems. And so what I'm doing is there was a fellow, Ceci released a tutorial last December that really explained the ins and the outs of the entire crowd system. And I'm going through that so I can really learn and master the crowds. Now, one of the things that I also realized that I don't have a real good grasp on are VDBs, and that is the volumetric rendering tools that Houdini supports. Now, I think that Houdini and the folks over at Epic are in cahoots, and I think they're up to something. And I think that the folks over at Epic want the VDB tools that Side Effects is supporting. On a side note, there's this thing called OpenVDB, which is an OpenVDB source set. And Houdini is, as far as I know, the only system, only DCC that actually supports that. And I think, therefore, since it's the biggest commercial package that promotes this OpenVDB, I think this is a big selling point. And so I think therefore I want to learn what these VDBs are all about, and I really want to get a good grasp on it so I can show you folks next week. I think that's something that should be done. Okay. It's not the most beautiful fire. It's not epic, folks, but this is just for pure demonstration. Maybe we should have stuck with Roberto. Roberto never fails. That'll teach me to use some dummy head. Okay. Now let's go ahead. Let's save this. Thank you. Yes, we don't want to lose any of that information. All right, we've got our thing going here, so let's go ahead and drop in a ROP network. And we're going to call this dude fire output. Okay, you know what I forgot to do? One thing I also want to do is put an output sub into my Pyro import. And then I'm going to create an output. And I am going to get and retitle that as dude fire loop. Okay, good enough. Dude fire out, and then we're going to go ahead and inside of our ROP network, I'm going to drop in a VAT node, VAT, vertex animation textures. Okay, there we go. And I'm going to say VAT dude fire. Okay, and then we have our start and end all set. Render with take, that's fine. The method, we don't want soft. We're going to open this menu, and we want fluid, which means the topology is changing. And then we're going to click on the initialize for engine. Now for the SOP path, I'm going to go // pyro import. Is that what we want? Yep. Pyro import. Oops, gotta spell it right. And we want the dude fire loop. That's exactly what we want. Okay, we've got our dude fire loop, and then we are ready to boogie woogie. Now, we do have about 2,500 polygons in there, but I think it's okay, because remember, we did Sluggo last week, and Sluggo had 6,000 polygons, or 9,000 polygons. Well, it had a lot of polygons. So I think it should be okay. Okay, so we've got the fire loop, dude fire loop, and we've got that, and so for the target poly count, well, how many is this? Okay, so let's go ahead and get the final count from our poly reduce. So we'll go / pyro okay. Calculate optimal prune count? No. / oh, you know what, this is not correct. We have to do a CH. Okay, CH for a channel, and then double quotes, / and now we're talking / pyro import, and we want the poly reduce. Come on back, poly reduce. We're not doing well today, are we? All right, we've got the poly reduce, and then we want the final count. All right, now close quotes on that, close parentheses, we should be good to go. And is this working? Yep. Wow, 2,514. That's a big number. Okay, but that should work, I think. All right, make sure to turn the pack normals into alpha, make that equal to false. And that opens up this, and we want to make sure to export color map equals true. All right, so we want the color map, and so for the export, we want to put the export in there, and we want to call this dude fire. And then for the component, let's call this dude fire. All right, I'm going to save, and then let's go ahead and render it out. This should be fairly quickly. All right, all done. Very good. All right, let's open up our UE4 project. And let's get out of this Roberto and create a new folder in our VAT, and we're going to call it Dude Fire. Create a new folder, call this Dude Fire. Okay, so let's create a brand new level for this. So I'm going to go File, New Level, Default. Okay, we've got that. Nice. Let's save current. And then we go to Dude Fire, and let's call this the Dude Fire level. All right. Good. All taken care of. Okay, so within here, let's go ahead and import all of our texture maps in our mesh. So import to Game Fire, and so we want Houdini, lectures, render, no. Oh, this is like the wrong thing. Let's say work, and where is my project? And I believe my project is, I'm having a brain fart. Where's my project? It's a D ticker. Okay, I know where the project is. Thank you. Import again. It's on the D drive. I was looking in the wrong drive. All right, and we have ticker EU, Houdini secrets, and then we have HSL VAT, export, and then we have Dude Fire. And now here we want to bring in our mesh information. Here's my thir mesh. Then we're just going to leave everything as import all. And then let's go ahead and bring in the textures. I'm going to go up to here to textures, and we have the thir color and the thir information. Now we should have had the normal information too. And will we need the normal information? Yeah, I think we will, because we need to get orientation. So I didn't export something right. So I'm going to go ahead and open these, and I'm going to go back into my Houdini to see where I didn't. I forgot to click on normal. There you go, folks. And it says pack normals into. See, we turned that off, didn't we? Yeah, we did. Okay, so we got to have the normals up one place, so let's go ahead and re-render. Alright, let's go ahead now and bring in our normal map. Alright, normal, okay. Remember, the normal is going to store our orientations for our rotations. So this is really cool. Let's take a look and see what's happening here. Okay, look at this. This is nothing but bukus of triangles. They're just floating right here in space. That doesn't look like the head that we created, and certainly doesn't look like fire. All right, what these are abstract triangles, and therefore the position and the orientation are going to control each of these triangles' position and orientation. And so it's all going to get put together dynamically into this, but we're looking at the polygons in a very abstract, intricate layer before they're actually put together. And so that will enable us to have a dynamic number of polygons into the scene. All right, so we've got, I'll go ahead and save this. Oh yeah, I have to process my textures. Oops, okay. I'm going to change this to vector displacement, and then for the filter, change that to nearest. Save. Okay, here's my color. Yeah, this color is stinky. I don't like it. All right, my filter goes the nearest. Okay. And then we had to get the position. Yes, get our normal position. Vector displacement. No, vector displacement. All right. And then filter it to nearest. And then save. Okay. Now, if you can remember, this is exactly what we did in the last 3 VAT exercises. What we did was we first create a material function. So I'm going to right-click on here, go to Materials and Textures, and I'll lay down a material function, and I'm going to call this VAT Fluid MF. VAT Fluid underscore material function, or MF. All right, I'm going to get rid of my output. Yes, we don't want that. And so for our explosive library, yes, and our library group, we're going to call this VAT Fluid. All right, there we go. Now let's go ahead and get the material function from Houdini. Houdini, we'll give it up. Okay, I'm going to change my VAT node where it says user interface simple, and change that to interface normal. And then I'm going to come down at the bottom where it says sample shader code. Click that. And then it says copy fluid material. Okay, I'm going to click that. All right, now I'm going to go back to UE4. Go back to our fluid function and just hit Control V to paste. And it just pastes it right up there for us. All right, thank you very much. That's just what we want. Okay, go ahead and save. Now, hopefully we're done with that. So now let's go ahead and create a new material. And I'm going to call this VAT Fluid underscore M. Alright, and then I'm going to look for my VAT fluid material function. Here we go. Alright, let's hook this up. We're going to hook up color. We're going to hook up normal. We're going to hook up world position offset. And then, oh, look at that. We need a bunch of extra UVs. So I'm going to first hit the tangent. No, wrong node. I want this. Give us a tangent. We're going to have to make sure the tangent normals, space normal is false. And then for the UV, the customized UVs, we want 3. Alright, then we've got UV1, UV2, and UV0. Alright, so let's go ahead and create a scalar parameter for our speed. So the scalar parameter, and I'll call that speed. Hook that up to here. Yes, thank you very much. And so let's go get our texture maps. I'm going to pull this down here. Give myself a little bit of room. And then 1, 2, 3. I'm going to go ahead and drag that right there. Alright, let's go ahead and organize these again. So for here, this looks like the position. Yes, it is. So right click on here. So convert to a texture object. I'm going to drop this into position. This looks like my normal. So I'm going to right click, convert to texture object, and drop this into the normal map. And going to do the same thing for here. Right click, convert to texture, put its RGB color output to the color map, and we should be almost just finished for this material. Okay, I'm going to hit save. Alright, now let's go ahead and create a material instance for this material. Alright, right click on here. Oh, here we go. Here, create material instance, and I'm just going to leave that as, oh wait, this is for the dude. So we're going to call this fluid dude. Or that's right, we call this dude fire. Dude fire. Okay, there we go. Let's double click to go into that. Okay, we're going to expose speed, number of frames, position min, position max. Okay. Everything else is going to be loaded in, so let's go back to Houdini and get our values. Okay. Our speed is 0.25. That's nice and simple. And our frame range is 120. And 0.25, and so position min is that. And where's my position max? Okay, click that. Click back onto here, drop this into position max. Okay, it's looking like poop. Okay, but that's because this is what the sphere looks like when we put this. Well, in the preview mesh, let's put in dude fire mesh, and ooh, now we're seeing some interesting things. This kind of looks like fire, man. How about that? It's kind of freaky. Okay. Let's go ahead and save this and then drop this into the level. Okay, we can go and drop my dude fire mesh into there. And this is actually kind of small, but there it is. And we're going to drop in the dude fire mesh instance as the material. And voila, we have a very small fire. This is much smaller than I was expecting. Okay. You know, other than the clipping at the top, it's not bad. Okay, so if we were to play this, we have is a very angry stock of asparagus here, folks. It's coming to kill us. It will get you. Attack of the killer asparagus. Okay. No, don't think it's going to work today. All right, let's see if we can somehow jazz this up a little bit. It's okay, but let's see if we can change things around in the material to kind of make it look like an angry piece of asparagus. Okay, I'm going to drop into my material here. So let's go through it, put some stuff in here. Let's go and add a constant material. Oh, let's see. Let's go ahead and make it a vector parameter. So we'll go parameter. So give me a vector parameter. Vector parameter, we're right on it. And we're going to call this constant color. So I'm going to call this flame color. And then what color do we want? Well, since we've got asparagus on the mind, let's go ahead and call it some kind of green color. If just for the novelty, however, I don't think we're going to stick around for that for long. Okay, we've got the green color. Now, let's get a Fresnel operator. You go, Fresnel operator, what is that? Okay, it's actually a French word, and the French do not call it Fresnel. That is not a good word. But what we have called it is Fresnel. So let's go ahead and get the normal. I'm going to pull my normal in and drop it over here. And my exponent here is at 5. Let's change it to 3. And the base reflectance, put that off to 0. Okay, so what the Fresnel component does is that it makes stuff looking like it compares the camera angle versus the normal angle. And the more perpendicular the normal is with the camera facing vector, then the less value it has. And the more orthogonal or 90-degree it is, then the greater the value is. And hence, that is the Fresnel operator. So what we want to do is, right in the middle, we want this to be almost transparent, but on the edges we want it to show up. And that's where the Fresnel information is going to come from. So if we multiply our flame color by our Fresnel operator, and then drop that into base color, and we'll go ahead and drop that into emissive. Ooh, because this is fire, right? All right. Also, in order to get this looking kind of wild, we don't want it to be opaque. What we want to do is to get it to look a little transparent. So let's make it additive. That should make it good. So I'm going to go ahead and make that change. Let's go ahead and save that. Okay, there we have some nutty looking green fire. That's pretty small. But as you can see, like right in the middle, it has kind of like a transparent green color, and then as we look over to the side, it kind of fades off. But that's when we're dealing with the Fresnel operator. Okay, now there's still other additions that we could make to it. Okay, so this is like just a simple, this is just like a hard color. We could actually do more to it. Well, let's go and create a color ramp. So let's say we want to make this kind of a green or a kind of a red, kind of natural looking real fire. So let's see if we can do about that. So I'm going to come up here, and I am going to create a new cop node. So inside my scene, let me save this. Don't want to forget it. I'm going to click on here, tab, and then go into ROP node, my ROP network, and then I'm going to call this color ramp. I'm going to drop that into here. Okay. Oh, what we wanted to do is I wanted to see this into contextually. So I'm going to click on plus, and then I want to have a viewer for my COP network, my compositing network. Let's see, viewers, composite view. Yeah, that'll work. Okay, very good. That's all we want. Okay, I'm going to drop in a ramp node right in here. So give me a ramp node. Wait, this is a rock layer. This is not a composite node. That's what? What? Yes, dude, fire out color ramp. No, this is not a rock network. I can tell the week is getting long here, folks. Give me a composite network. So I'm going to do comp. So cop2 network. That's what we want. Color ramp. IJI. Things are just out of control. Okay, let's get a ramp. Okay, I'm just going to pull out on this. Oops, I didn't want to do that. All right, very good. We've got a ramp going, and so where it says points, where it says 2 points, I'm going to change that to 4 points. So we've got 4 points of information that we're going to start dealing with here. Okay, so for point number 2, I'm just going to make that kind of, let's make it kind of reddish color. So 0.75, and then make this 0, make this 0, and make it 1. So that's going to be, definitely a good red color. Point number 3, we're going to make this at 0.6, which is kind of like a little bit more than the middle. Yeah, see, we got 0.3 sitting over there. I want to make this a little bit yellowish color. So let's make this 0.5 and then 0.25 and then 0. No, this is purple color. Okay. No, this needs to be a... Okay, this is not what we're looking for. We want a yellow color. Why is this so hard for me? Okay, 0.5 and it goes down to 0. So that's, I thought I put that in there. Well, I guess I'm smoking crack here, folks. So let's go down and put a dark yellow here at the corner, 256. Right for the corner here. And this is 0.2145. And this is 0.0172, 0.1072, and then for this blue value, we don't want purple, we want it to just be kind of a yellowish color, a yellowish orange. Okay, so we have this natural color ramp that fades from black all the way to orange to yellow and then to red. Okay, for my image, I'm going to make sure to change the size to override size. Let's change this to 256 by 4. And so it's itty bitty. But that's all we need. Oops, I don't want that. Stop it. 256 by 4. Okay. That's all we need. So I'm going to right put on here. I'm going to click over here. And I'm going to click in output. RAW file output. And then this is only 1 frame, so this is only 1. And then I'm going to click over here, and I want this to go to my texture folder, job, texture, and here we have color ramp, and I'm going to make this as color ramp. Click accept. Okay. Now you won't have color ramp on yours, I just want color ramp for mine. And now we've got that set. Go ahead, hit save. And then I'm going to go ahead and hit render. All right, cool. Now it's outputted, so let's go ahead and pull that into our UV4 project. Pull that into here, and then go up to HSL VAT, go to where it says texture, color ramp, JPEG. Okay, there we go. There's our color ramp. Now, even though we made it real small, you'll see that when we brought it into UV4, UV4 does the appropriate necessities in order to make it look nice. Okay, let's go ahead and adjust the material to handle our new color ramp. Okay, we're going to since we're going to be dealing with texture coordinates, let's go ahead and grab the text coordinate node. All right, now what we have to do is we have to change the coordinate index is to 1 because our object has more than one texture coordinates on here. One stores the actual texture information, one stores the actual VAT information. We want that, and that is stored in texture coordinate 1. Okay, but I only want the red channel on this, so we just want one channel on here. So let's get the component mask. And we only want the red channel. And then we're going to clamp this thing between 0 and 1, just in case there's any opportunity of any of these numbers going out of awry. I want to make sure that they're clamped. And so by default is between 0 and 1. Now I'm going to bring in a texture parameter node, texture parameter 2D, and we'll call this color ramp. And let's go bring in the color ramp. Oh, it already has color ramp already in it. That's UE4 thinking for us. Isn't UE4 nice? Very cool. And now what we should be able to do is take this value and then multiply this against our Fresnel component. Instead of the icky green color, we're going to want some luscious orange fire. All right, go ahead and click Save. All right, now we go in here, and ooh, look at this. We have a fire now. It kind of looks like it kind of like behaves out there, and it kind of is transparent. And we have multiple colors here. I'm wondering if this would look better if instead we made it additive. If we use one of the other ones. Additive makes it look very transparent. What if we use translucent? This might not work at all. Let's give it a check. I'm always willing to check things out and try things out. You never know what's going to happen. Sometimes serendipity can be a lot of fun. Ooh. Okay, it definitely makes it look very kind of stylized, almost kind of like a almost kind of anime-like. So, there we have two different perspectives. One is a raging fire that's a little bit more toon-shaded, and I think I still like the additive more. So I'll stick with the additive. Okay. Well, there we go. This is how you get abstract material without a defined number of points into there. And we have 2,500 points, and things are looking pretty good. So that really does work. All right, folks, that is what I wanted to cover with you folks today's session. And this was the third episode of VAT where we covered fluids, fire, and volumetrics. Now, depending on how you render this is going to really influence how it's going to be finally used. And so here we're using this as kind of like as a pseudo green fire. All right, let me see if I can wrap things up here. All right, so if you think this was pretty cool, come out and check us out next weekend, next Friday that is. That will be the 12th of February. And we are going to be talking about VDBs. Hopefully I can learn enough VDBs to make a passably interesting lesson for next week. And check us out for Tech Art Talk Live next Friday as well. And that's when we'll be dealing with Python classes. We deal with Python functions and data types today. Next week we're going to be dealing with an introduction to Python classes. All right. now, oh, let me see. Let me check out what's going on here. You guys didn't see anything. I've got to work on that. Okay, where is my broadcast? I don't even think it's being broadcast. Well, then blow me down. Okay, well, let's get this up and going, folks. All right, so let me go get this going. I've got to get some kind of display going here. Nope, it ain't having it. All right, let's see if it displays here. No, it ain't having it. Okay. Okay. There's more than one way to skin a cat. There you go. All right. Excellent. So once again, here it is. Yeah, 212. Check us out for Houdini Secrets Live, where we're covering VDBs, and check us out for Tech Talk Live, where we're talking about Python classes. Yes, once and for all. All right. Now, if you like what you see, go ahead and subscribe to this YouTube channel. It's really cool. We're going to continue putting out lots of stuff next week and for weeks oncoming. My name is Chris Rhoda. Check me out on Facebook, LinkedIn, or check out thir, also on Facebook and LinkedIn, and go ahead and join up with the group, or subscribe to my channels, or say hello, or whatever you feel like. But if you really want to help me, bop on over to the thir.com channel, and then where you see this little banner with this click here now, go ahead and click into that and sign up, and then give me your information so I can put you on my mailing list and keep you up to date with all of the goodies that are going on here on thir. We're making vast progress on the real-time visual effects for technical artists project. The project has really gone into high speed once Emma Condi has come on board, and Yolanda has also joined on, and she's doing some really excellent work. And we're making steady progress on the procedural gems. I'm currently working on the Eric Hansen interview, and that is my second to last interview, so expect that to be coming out very soon too. So you want to be in the know where all this groovy stuff is coming out, so come on by and check this stuff out, and drop into thir and tell us what you did, and drop me a line. Anyway, thank you very much for allowing me to share my afternoon with you. I hope you had a good time. I had a hell of a time. So I look forward to seeing you again next week. We'll talk to you later. Bye.